next section of the test deals mostly with the normal table. Question number 11 basically just asked me to look up two z-scores and find the probability in between by doing larger table value minus smaller table value. It gives me the z-scores negative 1.48 and 0.65. So I'm going to go to my table. For negative 1.48, I'm on the side with the graph at the top. I move down to the column negative 1.4 over to 0.8. When I line those two up, I get a table value of 0.0694. P equals 0.0694. I'm now looking on the positive side for z equals 0.65. When I look up, I go down the left-hand column to 0.6. Then I go over to the right to the column 0.05. I get that p-value to be p equals 0.7422. Now that I have the two p-values, in order to find a between question, I do larger p minus smaller p. So this becomes 0.7422 minus 0.0694. If I put that into my calculator tells me that 0.7422 minus 0.0694 gives me an answer of 0.6728. Question 12 is a little different. This is one where it tells me what's in the middle of the table as a probability and asks me to find the z associated with that probability. So first I need to know which side of the table I'm on. If I'm on a probability that's 0.5 or less, then it's the negative side. If it's 0.5 or greater, it's the positive side. Since 0.9306 is greater than 0.5, I'm going to be on the positive side without the graph. As I go down that first column, the thing that I see that's greater than 0.93 is 0.9332, and that's occurring in the 1.5 row. So that means the actual thing I'm looking for, 0.9306, must be happening in the row above. If I move over to 1.48, I see that that's 9.3 or 0.9306. So in this case, z equals 1.48 is the correct z with that probability to the left of it. Again, everything in this table is probability to the left. So here, the probability z is less than c, or the probability to the left is 0.9306. That's just tracing me back to a specific table entry. For number 13, we're first going to need to calculate the z-score formula. After we do that, we'll be able to look up the p-value, or the table value, and then because this is a greater than question, we'll do 1 minus that table value. So the first thing we're going to do is set up that z-score. Z equals the probability that we're trying to find, so this 1.37 is our point of interest, minus the mean of 1.3, divided by the standard deviation of 0.15. When I put that into my calculator, I get 0.07 divided by 0.15, which equals 0.4666 repeating. Remember that our table only goes to 2 decimals, so here I'm going to knock out these. Because what I'm knocking out, this decimal right here, is 5 or larger, this goes up and becomes 0.47. So really I'm looking up z equals 0.47 in the table. When I look that up, 0.47 gives me 0.6808 as my p-value. If this had been a less than symbol, I could stop right there and give that as my answer. Because it's a greater than symbol, I need to do 1 minus 0.6808. That's how I get to my correct final answer of 0.3192. Question 14, you guys have seen a bunch. It was on the original homework, it was on the test on the material, and now here it is on the final. Hopefully it's straightforward at this point and you know how to set up these problems. When it asks the proportion between 4 and 6 inches, I'm going to need to find z-scores for each. So the z-score for 4 is going to be based off of 4 minus the given mean of 5 divided by the given standard deviation of 1.5. For z-score for 6, it's going to be 6 minus the mean of 5 over the given standard deviation of 1.5. So when I first do it for 4, I get negative 0.666 repeating, which we're going to call negative 0.67. When I do it for 6, I get 0.666 repeating, which we're going to call 0.67. Now that I have those two values, I need to look up the table value associated with each z-score. On the negative side, negative 0.67 points me to a p-value of 0.2514. P equals 0.2514. When I look up the table value for 0.67, 0.6 over to the column mark 7, that gives me a p-value of 0.7486. Last thing I have to do is take larger p-value, 0.7486, minus smaller p-value, 0.2514. When I do that in my calculator, it should tell me that 0.7486 minus 0.2514 equals 0.4972. When I get to part B, where it asks me the proportion less than 4, I don't have to do a new z-score. I already have the z-score for 4 here. I already have the table value. In this case, less than is the exact table value, so I don't need to do 1 minus. I don't need to manipulate it in any way. This is the correct answer. It's 0.2514. For the last one, it's worded a little weird that I know tripped people up the first time they saw it, but really what you need to take out of it is you're looking for ones that are too big to fit into the tree holder. This says your tree holder is 7 inches, so we're looking for what's the probability we get something with a diameter greater than 7 inches. First thing we have to do is find that z-score for 7. So 7 minus 5 over 1.5. When I put that into my calculator, I get 1.33 repeating, which I'm just going to call 1.33. When I drop the extra 3, since it's less than 5, I don't round up. Now that I know my z-score, I look up the associated p-value, 1.3, move over to 0.03, and I get a p-value of 0.9082. P equals 0.9082. But what that really represents is the proportion of trees that are 7 or less. Really, this is all the trees that will fit into my new tree stand. In order to find the ones that won't fit, I need to find greater than or 1 minus that table value. If I do 1 minus 0.9082, that should give me 0.0918, which is the correct final answer to that question.